Welcome to the Connector Laboratory here in sunny Pleasanton, California. What we do here in the Connector Laboratory is different from our other laboratories in that we develop products mainly for the wood-to-wood connections. People don't really realize how much effort goes into developing a little piece of steel that's bent and used for construction, but we spend a lot of time and effort to make sure that we have great data that makes for good products. So this particular product that we're testing is our ITS hanger, and it's a top flange hanger that is attached to a wood header. We've got a joist with a loading bar that's going to spread the load out that we're transferring to it, and we'll take, and this actuator will apply a load until it sees the ultimate capacity. Along the way, we're also recording the deflection that we're going to be measuring throughout, and we're going to be examining what the load is at 1/8 of an inch of deflection as we go throughout the test. All right, here we go. Testing in 3, 2, 1. 3,000 pounds. Right now it has about the amount of load that we would assume that it would from a design standpoint. So you can see there's no damage at all to the part at this point. Now we'll take it up to the ultimate failure. So we can easily call failure. It's definitely done getting load. So you can see that the wood is completely split out and the top flange has failed. So the part is starting to slide off. And if we let this run forever, this thing would ultimately just pop this piece of wood right out. For this test, we're going to be testing one of our HDU hold downs. A hold down is typically used in a shear wall to provide overturning restraint for the wall. So what we've got is our HDU hold down that is attached to a wood post. Okay, the wood post is attached to the actuator, which is going to pull up, put an uplift force on this post. The hold down is anchored to the test bed using this big steel plate, which is attached to the test bed. And so as this pulls up, this is restrained from lifting up by this big steel plate. For this test, we're going to be looking at the capacity of a hurricane tie. Rather than pulling up on the setup, we actually have inverted it so we can push down and simulate the uplift forces on the product. What we'll learn from this test is we'll learn what the capacity of the hurricane tie is to be able to support the loads in our catalog. So what you can see is that we've got a pressure treated wood test going on. We've got multiple pieces of pressure treated wood. We hold the temperature at 120 degrees Fahrenheit and the humidity at 90% humidity. And we expose the wood for multiple days. Here's an example where we've got 2 pieces of wood that we dowel together with a piece of steel in between. And so this piece of steel is uniquely identified. We've weighed the sample beforehand, and then we'll be weighing it after the test is over. Right now it looks pretty clean, but as the test goes, you'll have different levels of corrosion. This is our salt spray booth that we use to evaluate different types of coatings that we have on our product. It's 100% humidity at 35 degrees Celsius, and there's a mist that is sprayed constantly throughout the test, and it's got 5% salt concentration. We examine the samples at various times throughout the test and do a visual inspection on how much rust that we see on the parts. What Simpson does in product development and in support of our customers and in training and education is making the world a safer place. What we're doing is definitely making a difference.